given f of x is equal to summation r is equal to 1 to 10 cot inverse of 1 minus of x plus r whole square for x is greater than or equals to 0, and we need to find the limit extends to infinity tan of f of x plus secant square of f of x. So let us consider cot inverse of, let us simplify this, cot inverse of 1 minus of x plus r whole square. So which can be written as cot inverse of 1 minus of x plus r is taken common. So we can write 1 minus of x plus r. So which is equal to cot inverse of 1 minus x plus r into 1 minus x minus r. So this can also be written tan inverse 1 upon 1 minus of x plus r into 1 minus x minus r, which is equal to tan inverse, the numerator 1 we can write it as 1 minus x minus r plus x plus r, which will give 1, and the denominator 1 minus of 1 minus x minus r into x plus r. So we know that tan inverse of a plus b divided by 1 minus ab, which is equal to tan inverse a plus tan inverse b. So here we can write tan inverse of a, that is 1 minus x minus r plus tan inverse of x plus r. So let us simplify. Since f of x is equal to summation r is equal to 1 to 10, so cot inverse can be written as here tan inverse of 1 minus x minus r plus tan inverse of x plus r. So we can write f of x is equal to, if I take r is equal to 1, you'll get tan inverse of 1 minus x minus 1 plus tan inverse of x plus 1, and again plus tan inverse of 1 minus x minus 2 plus tan inverse of x plus 2 plus, and so on, tan inverse of 1 minus x minus 10 plus tan inverse of x plus 10, which is equal to tan inverse of negative x plus tan inverse of x plus 1 plus tan inverse of minus x minus 1 plus tan inverse of x plus 2, and so on up to tan inverse of negative x negative 9 plus tan inverse of x plus 10. So which can also be written tan inverse of negative x, we can write minus tan inverse of x plus tan inverse of x plus 1, and tan inverse of negative x minus 1 we can write minus of tan inverse of x plus 1 plus tan inverse of x plus 2, and so on, minus tan inverse of x plus 9 plus tan inverse of x plus 10. So here we can cancel. So tan inverse of x plus 1 and minus tan inverse of x plus 1. Similarly, tan inverse of x plus 2 will get cancelled from the next term. And similarly, tan inverse of x plus 9 will be cancelled with the before term. So at last will be remaining. So it is left with tan inverse of x plus 10 minus tan inverse of x. So we have f of x is equal to tan inverse of x plus 10 minus tan inverse of x, which is equal to, by using the formula, tan inverse a minus tan inverse b, which is equal to tan inverse of a minus b divided by 1 plus ab. So here we can get tan inverse of x plus 10 minus x divided by 1 plus x into x plus 10, which is equal to tan inverse of 10 divided by 1 plus x square plus 10x. So we have tan of f of x is equal to, which is equal to 10 upon 1 plus x square plus 10x, and also secant square of f of x is equal to 1 plus tan square of f of x, which is equal to 1 plus 10 upon 1 plus x square plus 10x whole square, which is equal to 1 plus 100 upon 1 plus x square plus 10x whole square. And hence now the question, limit x tends to infinity, tan of f of x, that is 10 upon 1 plus x square plus 10x plus secant square of f of x, we can add 1 plus 100 upon 1 plus x square plus 10x whole square. And here clearly the numerator degrees, it's a constant, so degree is 0, and the denominator degree is 2. Since the numerator degree of numerator is smaller than the degree of denominator, and when x is approaching towards infinity, so the fraction will become 0. So we can say the first one is 0 plus limit extends to infinity 1, that's constant is 1, and again here so the degree of numerator is 0 and degree of the denominator will be is equal to 4, and the numerator degree is smaller than denominator degree, and hence we can also say that as limit extends to infinity, the fraction will become 0. So 0 plus 1 plus 0, which is equal to 1. So therefore we can conclude that the answer is 1, which is option C.